Hi, I'm David Fuller from the Eyes on the Sky video series. Let's look at stargazing basics, starting with understanding directions in the sky. Most of us are already familiar with the cardinal directions of north, south, east, and west. These can be further split into 16 subdirections like southwest or south-southwest and south-southeast. But all that really tells us is what direction we are looking from our location, and at best, really only in areas close to the horizon. Not only that, just as the sun rises in the east and sets in the west, the stars in the night sky also rise in the east and set in the west over the course of a night. So how do we discuss other aspects of the sky? Well, let's start with those cardinal directions again. If we split the sky exactly in half, from north to south, we would have a line bisecting those halves. That line is called the meridian. This line never moves because it always divides the sky from north to south. Now, if we locate the exact halfway point of the meridian, we're looking directly overhead, and that point in the sky is known as the zenith. So what other locating features in the sky are there? Although we don't see stars during daytime, the imaginary line in the sky that the sun traces as Earth revolves around the sun is called the ecliptic. Since the planets in our solar system orbit our star largely on the same plane as each other, kind of like a giant pizza with the sun in the middle, the path of the moon and planets in the sky closely follows this line of the sun. This imaginary line appears lower in the sky during the summer and higher during the winter months at night. So close to, or sometimes right on, the ecliptic is where we will always find the naked eye and telescopic planets in our solar system and the moon. Now keep in mind that the sun doesn't actually rise or set. What's actually happening is the Earth is rotating. We just don't feel that rotation because we humans are just along for the ride. So as Earth spins, imagine if you were standing at the North Pole and looked straight overhead when it was dark. The stars would appear to spin around a circle, and the axis of that circle at the zenith, the point overhead we talked about earlier. That point in the sky around which the stars rotate is the celestial pole. Of course, you likely won't ever see that because no one lives at the North Pole. So as we move downwards in latitude in the northern hemisphere, that point in the sky around which the stars rotate will move down towards the north part of the horizon. If you're in the upper latitudes, it will appear higher in the sky. The nearer you are to the equator, the closer that point is going to be to the northern horizon. If you've ever looked at a globe with latitude and longitude lines on it, you can probably imagine pretty easily our next set of markings in the sky, the celestial sphere. To locate objects in the sky, we use coordinates like on Earth, but instead of latitude and longitude, we project those lines out into space as if they were on a transparent sphere surrounding Earth. And these are called right ascension and declination. Right ascension is actually easy to remember. If you face north and the sun rises in the east, which side of your body is that on? Well, it's on the right side. So the sun ascends from your right, or right ascension. These are like the longitude lines on Earth that start at one pole and run to the other pole in equal spacings. Now in right ascension, they're listed in hours and minutes, and the 0 hour for right ascension begins in Aries the Ram, which is a zodiac constellation. Easy enough, right? And declination is simply the number of degrees away from the celestial poles. So the degrees from the celestial pole to the celestial equator is 90 degrees, the equator itself being 0, just like the degrees from our North Pole to our equator on Earth. With me so far? Great. So let's review these quickly. North, east, southwest never change, of course. The meridian splits the sky in two halves from north to south. The zenith is directly overhead. The ecliptic is the path the sun takes in the sky, along which the planets largely appear to follow. The celestial pole is the spot in the sky around which the stars appear to rotate as the Earth spins. The celestial sphere uses similar coordinates as longitude and latitude, but are called right ascension, and declination. Not hard at all, right? Okay, right ascension and declination may take a bit getting used to, but the rest should be pretty straightforward. In the next video, I'll explain how to understand the difference between brightness of objects in the sky. Thanks for watching. I'm David Fuller. Keep your eyes on the sky and your outdoor lights aimed down by using dark sky-friendly lighting fixtures so we can all see what's up.